Now I'd like to introduce our speaker for today, Cosmos Voutsinos. He hardly needs an introduction, as he has presented to SACPA 4 times since 2006. He's a mechanical engineer from University of Waterloo with a long history in energy systems analysis. His previous talk summarized the intensive analyses of Alberta's oil sands production problems, sustainable energy without hot air, and Canada's energy strategy with Kent Peacock, and the failure of the Canadian nuclear industry to adequately communicate the benefits of nuclear energy. He recently participated in the 2016 International Conference on Environmental Science and Engineering held in China. He presented a paper there titled "The Clash of Energy Supply and Climate Change." He encountered fresh ideas there pertaining to climate change and environmental assessment, which he will share with us. And as you can see, the title of his talk has been changed from Alberta's power grid, where will electricity come from in the future, to the clash of energy supply and climate change. Same thing, basically. Welcome to SACPA again, Cosmos.
Thank you, Dwayne. And good afternoon. Thank you for having me again. By the way, the reason I have made many presentations is because that's the only way I can get a free lunch. But I have to work at it. So, because I've made several presentations before, it is reasonable that some of you will have formulated an opinion or classify me, put attached like pro-nuclear or skeptic or whatever else. I really don't consider myself none of the above. What I think myself is as a pro-math. That means that we set a goal and we take steps to meet that goal. The steps we take have to be in the direction of the goal and has to add up to the goal. If the steps we take don't add up or they're in a different direction, I don't accept it, and I question it until eventually it adds up. It's just as simple as that. Now, when there is an area that I don't know, I practice what is called nullus in verba, which means sit down and do your homework, evaluate everybody's opinion, and then formulate your own opinion, rather than sort of accept someone's hearsay and go at it, because there is too much misinformation floating around these days. So let's start by recognizing that humanity, we have a problem. And that problem creates a clash between our energy supply and activities we have to take in order to correct whatever problem there is in the environment, in the climate change. People have been divided into three highly obsessed groups based on their own ideology. And the division is what action to take. One of the group is the Greens, or known also as environmentalists, alarmists, or politically correct people, that believe that immediately reducing the increasing rate of CO2 from the electricity production will solve the problem and save the environment and the planet. Then the second group is, I call the skeptics, some people call them deniers, or some people call them flat earthers, believe that IPCC has too much uncertainty in its science, and at some point it will be proven wrong. As a result, do nothing, live our life as if nothing has happened, and consume hydrocarbons. And the last group is what I call the nirvanas, or the anti-oil individuals. They believe that we can survive with energy supply by sunshine and breezes, and as a result, we should leave the hydrocarbons to the ground. All these obsessed groups don't communicate with each other other than throwing derogatory names on each other. any one of these ideologies, three ideologies, appears to be correct, but only if one looks at the problem from one single and very narrow point of view. That's the one the proponents of that ideology look at it. However, our world and our problems are much more complex, and a single narrow point of view, at least in my opinion, or a single ideology cannot really provide a complete and workable mitigating solution to the problem of environment. We need a panoramic view that can only be achieved by constructive communication between all the groups. On this podium a few years ago, there was a biochemist, and he told us how bad plastics are for the environment that we get packaging. So he was suggesting that we don't buy products that they are packaged. Someone of you got up and asked, what about the economy? He says, I don't know about the economy, I'm not an economist. It was a narrow point of view, which was correct from his own point of view, but from a universal point of view, it didn't make sense. Also, last year, a university professor in Lethbridge University was suggesting that leave the fossil fuels in the ground. When I asked him how we'll manufacture a next energy infrastructure to decarbonize, he said, I don't know. Here again, a correct point of view, but partial. I will show you here how and why the mitigating solutions proposed, but each one of these groups neither benefit our environment nor help humanity survive. And the reason is that we propose solutions without having a comprehensive, complete, and panoramic picture of the problem, so that all these mitigating solutions consider all the diverse points of view. Let me start with the largest group, the one of the Greens. Last December, happened in Paris. They signed an agreement, and the agreement said to help save the planet by controlling pollutants. This appears noble and correct in the first glance, but effectively, what this thing is doing, it demands a complete and massive re-engineering of our energy infrastructure. The Paris Agreement also, and this is a side note, states in paragraphs 4.1, 9.1, 9.4, 4.13, and 4.14 that carbon reductions alone will not be enough, and they should examine and enhance negative carbon options. This has been buried in the CO politics that has ensued after that, and I will come back later to that. Let's look at the CO2 emissions of Alberta. If you look at it, the CO2 emissions are a very small percentage from our electricity supply. In fact, electricity supply is only 17% of our total emissions. Right there, you say, that you have 46, I don't know if you can read the table, 46 for transportation, 11 agriculture, forestry, and waste, 9, building of homes, 8, manufacturing industry, 9. This alone, then, should tell you that what the Greens are heading for, and that's the majority of our population, doesn't add up to the right direction. It doesn't add up to what we want to do to save the environment from the CO2, because we tackle only a small portion of our problem. And that it's a very small portion. Now, let me give you a picture of our energy infrastructure. The table has the rows are the different categories of energy, and the columns are production, distribution, and consumption. We have residential energy, industrial energy, electricity, gas, transportation, and petrochemical. The key thing of that table, what I want you to get, is that when you move one of these sectors, everything else is affected. It is very balanced and interdependent. You can't sort of go and monkey around with one end of it and not affect everything else. Usually, when we build a building or a bridge, we complete a detailed study and analysis of the elements going into its construction. The problem, as I see it, is that some governments, including ours, have started to reconstruct our complete energy infrastructure without first taking the time to understand the full picture and the implications of their actions, and to complete all the necessary engineering, analysis, evaluations, environmental, economic, to determine what will be the for example, had anybody heard them talking about what is the carbon footprint of the mitigating solution? Nobody seems interested to that. Why? And I'll give you some example of some mistakes that have come back to haunt us. Dr. Andrew Leach, the head of our government's advisory panel, would like now to turn back the clock to revise some of his decisions. We have only less than a year since these decisions were made. What will be 20 years from now? These are long-term propositions. They're not short-term, not only long-term, but very costly, at the order of billions of dollars. Ontario Premier Wynne just announced that the government will begin subsidizing the high rates of electricity that have risen there because of the penetration of the renewables. They should have analyzed and identified the problems before they implemented the policies. The Ontario Auditor General had stated last year that Ms. Wynne's government has wasted tens of billions of public dollars in reckless pursuit of green energy. It's not the green energy the problem, it's the reckless pursuit the problem. Our very own MP, the Honorable Shannon Phillips, last week announced that 30% of our electricity will come from renewables and 70% from natural gas. Well, it sounds good. However, there is a difference between electrical capacity and electricity production. The renewables produce only 1/3 of their capacity. When she finds out the error, oops, now that will cost us about $20 to $30 billion more dollars. The example that I've given you here are not intended to belittle neither our MP or Premier of Ontario or Dr. Leach or the biochemist or the UFL professor that I mentioned earlier. They're intended to highlight here how complex and multi-phased our problem is and how decisions made superficially lead to misleading solutions that implementation of which comes back to haunt us. This point of the environmental cart being ahead of the environmental horse came up in the Environmental Science and Engineering Conference that I attended in China. And we discussed it quite extensively. And we all agree that there was a problem and had to be a solution. So Dr. Kwa Harm Wei of the Singapore University suggested some simple rules. Do not connect the dots and formulate premature decisions before you have all the dots available. Any mitigation proposal must be evaluated by all the specialists in the applicable disciplines before it is submitted. And then subject every mitigating proposal or idea to a rigorous life cycle sustainability analysis, LCSA, to define how the environment gets benefit from our mitigating actions, by how much, and how long does the benefit last. Because as humanity increases, we seem to increase the amount of CO2 emitted, and then we negate any benefit that has been gained from a mitigating action. On my return to Canada from China, the first thing that I did was to apply LCSA analysis to the climate leadership plan of our provincial government. I'm sad to tell you that it failed on all counts. It just doesn't add up. I don't make it. I wish it was different. It just doesn't add up. I wrote a guest editorial in the Herald and reported on this. If you have missed it, there is a papers outside of the guest editorial I have printed, I have made copies. Pick up one on your way out. Or we can discuss it later on. Remember that the current energy infrastructure is carbon-based and emits CO2 with every action we take. Even talking about it, we emit CO2. We have to ensure that the mitigation projects provide more CO2 savings to the environment than the penalties. In fact, the whole issue of mitigation projects becomes meaningless unless we can define the carbon footprint of the mitigating actions. So we can find how much have we gained. Have we gained or have we lost? Numbers do matter, and our government seems to leave them aside and go into it. and not all points of view are seen to be considered. Let me give you a couple of other examples of missing points. The Alberta's total emissions are 37 of Canada's total. They're higher than other Canadian provinces because almost half of Alberta's emissions, as you saw before with the CO2 emissions, originate from the production and export of oil and gas that contribute 30% to Canada's gross domestic product. Now, that's fine. All provinces get the higher gross domestic product benefit, but Alberta gets all the penalties. I ask you, what kind of advisor does a provincial minister of the environment has? She shouldn't be expected to know it on her own, but the advisor should be able to tell her that, to advise in that direction. Again, narrow points of view, ideology, blinds people, and keep going. And we pay dearly later. For some stray region, another one. For some stray region, Canada has accepted that it contributes 1.5% of the world's total CO2 production, without claiming any carbon credits for the vast borealis forest we maintain. This forest absorbs not only all our CO2 emissions, but something like 20% of the world's CO2 emissions, anthropogenic emissions. You remember the negative carbon paragraph in the Paris Agreement? Here we come. Again, I ask the same question. What kind of advisor our federal minister of the environment has? People are talking about carbon market. A market is a place where buyers and sellers are going to exchange a commodity. Who are the sellers? Well, some of the sellers are people that own renewables. When you own renewables, you earn RCCs, they call them, renewable carbon credits. So who are the buyers? The buyers are heavy polluters that buy the carbon credits to be able to pollute legally. So instead of the CO2 coming out of Alberta's power plants, it comes out of California, heavy polluter. I'm asking you, where is the benefit to the environment? As long as CO2 keeps increasing, at any rate, it doesn't matter whether it is slow or fast, the perceived danger will persist. And reducing only the rate of increase really achieves nothing, especially since we as people, the world population, keeps increasing. And then if the bathtub fills at a drop or at a flash, it doesn't matter. Eventually we flood and pour out. So what do we achieve? If this danger exists really, the only way the planet can be saved is to stop producing CO2, period. And the only way to stop producing CO2 is to decarbonize our entire energy infrastructure. All of it. Not only electrical production. Such a project at best would require a 10 to 20-year period for engineering, planning, scheduling, and testing of prototypes, and another 40 to 50 years period for building the new decarbonized energy infrastructure, and a few more years to transition and to debugging. As you can see, the mitigating solutions of the Greens doesn't add up. They concentrate on electricity, which is a small part of the perceived problem. Even that only solves a small part of the problem again, because CO2 keeps increasing, only slower. It's not stopping. Natural gas plants contribute CO2 at the half rate. So what? What is the problem? I mean, we perpetuate our dependence on fossil fuels by installing renewables without having thought out the problem and handled continuously. What is the benefit to the environment? This handicaps our ability to mitigate our problem later, because we head into an energy poverty situation. It will handicap a problem to react. So the whole effort of our government can be defined with one title: much ado about nothing. Now, let's examine the skeptics or the deniers approach. They believe that we should continue our dependence on carbon fuels because IPCC's projections are very uncertain and they will likely be proven wrong. I will illustrate it here that even if the Earth warming did not exist, this is not a solution. It would reduce the urgency to act, but it would not remove humanity's ultimate goal of eventual decarbonization, which will have to take place sometime in the next 2-3 centuries. There are reasons to proceed now, even if the anthropogenic global warming did not exist. And here it is how it works. On the demand side, there is not hope that we will abate our demand. We're an increasing world population that increases longer lifetime and expects higher standard of living. On top of this exponential increase, we'll have to add the energy that we will need to mine, manufacture, erect the new equipment to decarbonize. That will add up something like 30% for the 30 to 50 years of decarbonization transition. On the supply side, we see that it takes more and more energy to produce a barrel of oil. Originally, we had drill a hole in the ground, oil come out of this pressure. Then we had to go put a pump, then deeper and deeper, more energy, more energy. So what does it happen? We keep increasing the amount of energy input. ROI is energy return or energy invested. So what's happening? On the red line, the price of oil, of hydrocarbons goes up, and the availability of oil per energy we have to put in goes down. What will happen? At some point, we're not going to run out of oil. I think that what will happen is we're going to have to put 1 barrel of oil equivalent of energy to extract 1 barrel of oil, which defies the purpose, and that is what I call the cliff. As ROI decreases, the price of oil will increase. So the question I'm asking is, should we really wait until we reach close to the cliff to do the decarbonization, or we should do it earlier? We will have time, low-cost energy, and plenty of it. So again, the deniers or skeptics, the approach doesn't work. Let's examine the green nirvana's approach. Boy, I'm running out of time. Renewable technologies are intermittent. Every time a breeze is reduced to a zephyr, the voltage and the frequency in the grid will drop. And that, to prevent that, we require a massive amount of current going into the grid from some other power plant or a storage. Renewables can only work when we have technically and financially feasible energy capability to do that, to provide massive amount of current in short time and 100% of the demand for when we have not renewables, which amounts, strange enough to some of you, 8 months per year we have nothing. Even if we have the renewables, they don't work. It's produced only 30% of our time. And so if we put gas plants to back them up, where's the benefit? Still they emit 3/4 of the CO2 out of the atmosphere. It's not a permanent solution. Let's examine this. Examine the storage use. We live in prairies. It's a flat land that has no elevation, so we can't put pump storage. The only option is some people talk about batteries. Next time you go to Canadian Tire or to Costco or to the garage station, just look at the battery. What you will see is a plastic case or a hydrocarbon case. Ask yourself, what material other than form of hydrocarbon can be used that will not conduct electricity, will not get wet or be dissolved by the electrolyte, will be strong enough to contain the plates, will be stable, and have a reasonable cost? There is a lot more to a battery storage that you can meet the eye. Even when you put the energy in, you don't get it all out. A lot of it becomes as heat, it goes out. So if we leave the oil on the ground, how would we make batteries, tires? How will operate the equipment for farms, construction? How will the planes, trains, ships, and trucks work? Do anybody think that the vegetables and the fruit walk by themselves to the market? So the dream of the environment, again, doesn't add up. We're deploying renewables as fast as we can, and here's the kicker. However, has anyone seen environmental analysis done for the renewables technologies? I haven't. But we do this for everything else that we build. Why not? The first law of thermodynamics tells us energy cannot be created out of nothing, cannot be destroyed to nothing. It can only be converted from one form of energy to another. So this means that renewable technologies don't create the energy. They harvest an existing form of energy in our environment, and they only convert it to electricity. And the question I'm asking is, what form of energy they are tapping and harvesting the renewable energies? And what does it do to the environment? Does it have any negative effects? I think there are adverse consequences for them. And I will have enough preliminary work to back this conclusion. I will present it at some time to U of L as a research and development. In conclusion, I suggest that this is exactly the right moment to put aside all our obsessions and ideologies and to start working together to create a next energy infrastructure and a workable transition to it when we do have plenty of low-cost energy and time. The problem is difficult. It cannot be solved by heroic ministers trying to do it all alone. It cannot be even been done by consulting a couple of advisors or reacting to special interest groups. It will take a great effort from several disciplines. Our problem is multi-faced. The government needs to hire a diverse, independent, and interdisciplinary group of analysts to evaluate in great detail every pertinent factor. It will also need to examine the experience and the result achieved in countries that are some 30 years ahead of us on using the renewables. We should learn from the mistakes. Are we here leading or following blindly? I question sometimes. Finally, but not lastly, before signing 20-year irrevocable contracts for subsidies, the government must place a moratorium on the climate leadership plan, or at least pull back the throttle of the signing to extend the time for learning and understanding. Instead of buying commercials that end up misleading the least knowledgeable voters, the government, technocrats, and consultants and advisors should perform carbon cost-benefit analysis. At the end of the day, the government must be able to tell Albertans quantitatively, not qualitatively, how their mitigation efforts benefit our environment, by how much, and for how long. Thank you.